Hey, what's up guys? This is part 3 in the Getting Practical with Typescript series. In this video we're going to be talking about generics. We're going to be covering basic generics, just the ones that are useful in my opinion, and the ones that we'll be using in our day-to-day lives. So, to get started, I think the best way to explain what generics are is by using a practical example. So, if we think of a clone function that accepts an object and returns a clone of that object, so JSON stringify, JSON parse, JSON.stringify, and then the object itself. Cool. So now let's create a few interfaces. So we're going to say interface of person, who will have a name, which is a string. And then we're going to have an interface of an animal, and it's going to have a leg count, which is a number. Cool. And these are two completely separate objects. So let's create a person who is of type person. And this person has a name, which is Jacob. And then const animal, which is of type animal, is going to be equal to, with a leg count of 4. Okay, and now let's say we want to clone this person. So we're going to say cloned person is equal to clone person. Now you can see the issue here already is that cloned person is of type any. And this is a problem because the clone function we consider here returns any. But the thing is, we don't want it to be any, we want it to be of type person. And so technically we could say that this accepts a person and returns a person. But then, if we try to use the clone function const cloned animal equals clone animal, you can see that we will get an error because animal is not of type person. So this is really where generics come in, right? We want to say that clone has no idea what type it's going to be cloning. It just knows that it's going to be returning the same type that it accepts. So the way you do that is basically you say T. Really, this could be anything, but T is the convention for generics. And we're going to say T, the object that we receive through is also going to be of type T. And the return value is also going to be of type T. And if we go down here and we say that we are cloning a person, you could see now that cloned person is of type person. And if we go to animal, we could see that cloned animal is now of type animal. And just like that, we've created a generic function which is able to accept a object of an unknown type from within, meaning unknown from within this function, and return it out using generics. So let's go into a practical example of this. Is if we go to our map, you could see here that we just have a basic user map, which accepts a record of number and has a value of, it is a key of number and a value of user. But this isn't particularly reusable because if we want to create an animal map, we would have an issue. So let's sort this out and make it generic. So the first thing that we want is we're going to get rid of our interface, and we're going to get rid of our implements, the iUser map, and we're going to say that users has a record which is a key of type K and a value of type T. And K is also conventional to use for generics. So now K and T are undefined. We don't know what they are yet. So what we have to do is add in right after the class user map. And in fact, let's just change this to generic map since it's no longer going to be a user map. And we'll say that we're going to have K and T. And we'll see that the issue over here is that K within record only needs string, number, or symbol. It can't use anything else as a key. So we're just going to copy over extends string, number, or symbol. And we're going to say that K extends, let's remove that. And now we just have an issue over here that users KT is not assignable to an object. So all we have to do here is just say as record KT. Cool. So now that we have that, we'll see that we have a few more errors over here. So the first issue is that we see we're indexing by type number, but the index over here, or rather the key, is of type K. So let's change that to K. And the user is of type T, because that's the value. And the same thing goes for here. In our get, we're going to be accepting type K, and we're going to be returning void or type T. And the same thing over here is we're going to be accepting type K, and then clear, we have to do the same exact thing and just say as record KT. Now, I'm not sure if we discussed the as keyword. Basically, this is just our way of typecasting and saying that, listen, this is going to be of this type. Cool. So now that we have that, let's create our implementation over here. So the first thing we're going to do is be copying over our interfaces. Let's just comment out this whole file and put our interfaces here. So we're going to want to create a user map. So we're going to say the user map, the person map is going to be of type new generic map. It's going to have an ID of number, and it's going to have a value of person. And now we could say person.set. We'll just comment these guys out. We could say person.set. And you can see here that it tells us that we're expected to give it a type of number. So let's just say 0. And the object over here is going to be of type person. So we get the autocomplete with name of Jacob. And the same thing happens if we say result is equal to, so let's just make this person map. And we're going to say person map.set, and we're going to say person map.get ID of 0. So you can see here that our result is going to be a void or person. And by the same token, we can say that const animal map is equal to a new generic map that receives a number. Let's make it a string in this case, and a animal. Cool. And we can say animal map.set. And we can see here that it tells us we need an ID that is a string, so let's say 0, and an animal. Now the issue over here that we can see is that it says user, and that's just an issue that we have over here, that we named the property here user. So let's just say this is going to be called records, and we're just going to change users to records, and we're going to change user to record. And that way it's generic as opposed to being coupled to user. So if we look here, animal map.set, and our record is going to be of type animal. So we're going to say leg count of 4. And if we say const animal result, and we say animal map.get 0, you'll see that our result is either void or of animal. And that's the way that we're able to reuse the same code and use generics to, well, make it generic so that we can use person or animal. And if you really think about it, this is really what, if we take a look at the record type that comes with TypeScript, so let's just say m is equal, and let's give it a type of record. And you can see over here that record k extends string number or symbol, and we have t. So we can really say string and person and is equal to that. And the cool thing over here is that we can now say m1 is equal to a person. Is equal to name Jacob. And we just really implemented this functionality with the class, with our generic map class. But technically you can see right here that TypeScript is using generics under the hood to allow for these generic structures. Cool. So in the next video, we're going to be going over a more complex project. We're going to be probably recreating the subscriber design pattern, and we're going to be doing that with TypeScript. So I'm looking forward to seeing you in the next video. In the meantime, if you have any requests for other series or want me to explain generics a little bit more, just ask in the comments. And if you enjoyed the video, just subscribe because it'll help out. And I'll see you in the next one. Bye-bye.